Hello everyone, Professor Wolf here. I'm making this video for students in my Introduction to Philosophy class at College of DuPage in fall 2025. Here's the deal. Y'all completed an assignment recently, an assignment on logic. The assignment was called Arguments 1. And as I said, I want to make a video, here it is, in which I talk through with you the questions, the answers to the questions, explaining the questions and the answers in a bit more detail than we did in class. You might have gotten from the source material, and then you could use the video to revise, resubmit your assignment submission. Okay, so without further ado, let's get to it. Question number 1. How does Jeff Pin define deductive arguments in the first video? So I asked you to watch a few videos, all made by Jeff Pin, actually somebody I attended graduate school with, who was a professor of philosophy for many years at Northern Illinois University, now a professor at Elgin Community College. He made these videos. I asked you to watch the videos, to read a bit of a chapter by Elliot Sober, to answer these questions. So here we are, question number 1. How does Jeff Pin define deductive arguments in the first video? How did he define it? Well, it's the way that Sober did in his article. It's the way I did in class. It's the way all philosophers, mathematicians, computer scientists do. A deductive argument is a deductively valid argument, or sometimes more simply, we call it a valid argument. And here's the definition. It's an argument such that if all the premises are true, then the conclusion must be true. An argument such that if the premises are true, then the conclusion must be true. As I said before in class, as I said before in previous videos, to say that an argument is deductive or deductively valid, or more simply valid, does not mean that the premises are actually true. You have many deductive arguments, deductively valid arguments. Again, these terms here mean the same thing. Many such arguments where one or more, perhaps even all, of the premises are false. When we say that an argument is valid, deductively valid, deductive, we're not saying the premises are true. We're saying that if the premises are true, then the conclusion must be true. We're not taking a stand on the actual truth value, the truth or falsity of the premises or conclusion. We're looking at the logic. We're really looking at the question of whether the premises do provide support for the conclusion, and if so, how much. And this is captured as follows. If the premises are true, then the conclusion must be true. That's one type of support, the strongest form of support, deductively valid support, deductive support. Okay. All right. So there it is. And another thing that I like to emphasize here is that we are applying the term valid only to arguments, not individual premises, conclusions, statements, judgments, what have you. Only to arguments. We're applying this term only to arguments. We're dividing all arguments in the world, all possible arguments, into one of two camps. Those that are deductive, or we could say deductively valid, or we could say valid, and those that are non-deductive, non-deductively valid, invalid, right? And as we'll see, and as we have seen, there are many invalid arguments that are actually pretty great, right? And again, it can sound funny to call them invalid. I went over that at length in a previous video. I won't do all of that again here. All right, so that was question number 1. Question number 2, how does Jeff Pin define ambulative arguments in the first video? Sober does something very similar. He doesn't use this term ambulative, but Sober does something very similar. Ambulative argument, how does Pin define it? Well, ambulative arguments are non-deductive. They're non-deductive. We could say they're not deductive, N-O-T space deductive. We could say they're non-deductive, N-O-N hyphen deductive, right? They're not deductive, they're non-deductive, so they're not deductively valid, so they're invalid, right? But they're still good, like a truly ambulative argument, a successful ambulative argument is still good. Well, why? Right? If it's not deductive, that means that the premises don't provide 100% guarantee of the truth of the conclusion, if they're true, right? Still, is Sober says in these kinds of arguments, if it's a successful ambulative argument, the premises, if true, give you reason to believe the conclusion. They make the conclusion possible, or as Sober also puts it, he puts it in three ways: gives you reason to believe the conclusion, makes the conclusion possible, also raises the probability of the conclusion, or as he says, makes the conclusion probable. And this is the way that Pinn puts it. An ambulative argument, a successful ambulative argument, the premises, if true, do not guarantee the truth of the conclusion, but as Pinn says, they do make it probable. Sober says make the conclusion probable. Pinn says make the conclusion probable. I think we should say here makes it more probable, right? If the conclusion has some antecedent probability, and then you make an ambulative argument, you try to make an ambulative argument for the conclusion that doesn't raise the probability of the conclusion at all, doesn't take away, but doesn't raise it, I don't think it's really a good argument. Because again, with an argument, the premises are supposed to be giving you reason to believe the conclusion. So I think we want to be careful here. I'll say this again. Sober says that with an ambulative argument, the premises make the conclusion probable. Pinn says make the conclusion probable. I think what we need to say here, and I think what they really are saying, I think what they want to say, it's not just the conclusion is probable. It's that the premises are making it probable. That is more probable. I think that's what they mean when they say, like, make it probable. It's not just the conclusion is probable. It's the premises are making it probable. They're making it more probable, right? That's the way I think we should take them. That's the way I would understand it, right? And just to add a few more things here before we go on, I think one thing Pinn could be clear about, I think he is clear at points in these videos. He is explicit about it at points. I think maybe not always explicit about it, maybe not always clear about it. Again, go back to deductive arguments. He will sometimes say in a deductive argument, the premises guarantee the truth of the conclusion only if the premises are actually true. If the premises are false, all bets are off. You have valid arguments. Where premises are false, the conclusion can be false. If the conclusion is true, it's not because of the premises. That would just be an accident. Same thing with ambulative, right? It's like, in an ambulative argument, do the premises raise the probability of the truth of the conclusion? Well, if the premises are actually true, yeah, right? If they're actually true, yeah. And again, what we're looking at with ambulative arguments, we're looking for them to be true, right? For them to be true. Okay. And just really, quickly, why do we even talk about ambulative arguments? Why don't we just stick with valid arguments? Because you don't get 100% guarantees very often in life, right? There's lots of times where we do find it not only rationally permissible, but rationally compelling, right? And what do I mean? You could be irrational if you don't believe it. If you don't believe something on the basis of some evidence, where it doesn't, the evidence, the premises don't provide 100% guarantee of the truth of the conclusion, but do raise the probability of it significantly. Okay. All right. So for 3, how does Jeff Pinn define abductive arguments? As inferences to the best explanation, right? I think he gave this example of a conversation in which somebody blushes or somebody overhears something and blushes, and then somebody gives an argument for why the person blushed, right? And I think it was something about a crush, something like that. I don't remember the exact details of his. I just watched the videos again yesterday, but I don't recall the exact details here. But here'd be an example. Here'd be an example of an abductive argument, right? Suppose it's January in Chicago. You go to bed at night. There's no snow on the ground. You wake up in the morning. You look out the window. There's snow all over the ground. You say, it snowed in the middle of the night. That's how the snow got there. That would be an abductive argument. Here, premise number one. It's January in Chicago. I go to bed at night, no snow on the ground. Premise number two, I wake up the next morning, there's snow all over the ground. Conclusion, it snowed while I was sleeping. That's the argument. That's abductive. It's not deductive. It's not deductively valid. It's not valid. It is not deductive, non-deductive, not deductively valid, invalid. It's all, right? These are just all synonyms here, right? And you might say, well, why? Because there's not a 100% guarantee that if the premises are true, the conclusion's true. Why? Because it could be the premises are true, but the conclusion false. What does that mean? It could be you really went to bed at night in January in Chicago with no snow on the ground, and you woke up in the morning and there was snow on the ground, but it didn't snow in the middle of the night. Now, obviously that snow, we would say, has to get there somewhere. And actually maybe we should say no, it could have just swirled into existence randomly, right? Maybe we should be open to that. Is that a kind of explanation? Well, I mean, some would say yeah, some would say no. Maybe we're using the word explanation in different ways. But I mean, here's the deal. You know, normally we'd say there's got to be some other kind of more concrete explanation. What is it? I don't know. Michael Bay is filming Transformer 7 in your neighborhood and wanted there to be snow on the ground, but there wasn't, so he piped in snow. I don't know. The snow angels, wanted it to snow. I mean, whatever, right? There'd have to be some other explanation. Now, the thing is, those explanations would be really far-fetched. They'd be really unlikely, but they're not totally impossible. And because they're not impossible, the argument is not valid. It's not deductive. It's not deductively valid because there's no 100% guarantee. If the premises are true, the conclusion's got to be true. It's not valid because there are these other possibilities. But because those possibilities are so remote, they're so ridiculous. Maybe you say, well, is it really ridiculous? Michael Bay would film a movie in my neighborhood? Well, yeah, kind of. Well, it's ridiculous that he would do that and you would not even know about it. I mean, I'd assume if Transformer 7 were being filmed in your neighborhood, you'd probably hear something about it, right? You'd see some, that the crews would do all the work, just while you were sleeping, right? Okay. You get it. Like the other possibilities, they're out there. And so the argument's not valid. But those other possibilities, those other explanations, they're not plausible. They're ridiculous. This is why the explanation it snowed in the middle of the night. It's the best. It's the best. And I would say it's not even just that it's the best, it's also good enough. Sometimes the best is really crummy. Well, then maybe you shouldn't believe it at all. But here, the snowing explanation is not just the best, it's also really good. Why? Because it snows in January in Chicago all the time, right? And you can see how context sensitive this is, right? If you were like in Hawaii, maybe the Michael Bay explanation starts making a lot more sense, right? But in Chicago, it doesn't work like that. All right, so abductive arguments, we also often call them inferences to the best explanation. Inference means drawing a conclusion. Drawing a conclusion from some premises. That's what we mean by inference. It's like an argument to the best explanation. Abductive arguments are inferences to the best explanation. We are assuming that these facts, there's snow on the ground in the morning, they have explanations. There's all kinds of philosophical questions you can start asking. Are explanations real at all? Are they just in the head? Are they in nature? Where do they come from? Laws of physics, other things, what? Causation and explanation, all kinds of great questions. We're not going to get into those now. We make these arguments all the time. Your doctor does, your mechanic does, you do. We're assuming all kinds of facts around us, maybe not all, but a lot of them have explanations. And often we're willing to, venture an explanation, to accept an explanation, to buy an explanation that's not 100% airtight. Well, that's it. Abductive arguments, right? Okay. Number 4, based on the 3 videos, would you say abductive arguments are deductive or ampliative? They're abduct. Sorry, I wrote the wrong thing in my notes. Are abductive arguments deductive or ampliative? They're ampliative. They're not deductive. Went over that. 5, how does Sober define induction or inductive arguments in the 3rd chapter of his book? This is page 24. He defines them as statistical generalization. Quote, taking a description of some sample and extending that description to items outside the sample. You can write up inductive arguments in different ways. A classical way to do it is like this. Premise number 1, the first spider I saw was carnivorous. Premise number 2, the second spider I saw was carnivorous. Premise number 3, the third spider I saw was carnivorous. Premise number 4, the fourth spider I saw was carnivorous. ... the 10,000th spider I saw was carnivorous. Then we leap to a conclusion. All spiders are carnivorous. Here's another classical form of this. Premise number 1, the first piece of copper I tested conducts electricity. Premise number 2, the second piece of copper I tested conducts electricity. Premise number 3, the third piece of copper I tested conducts electricity. ... Premise 10,000, the 10,000th piece of copper I tested conducts electricity. And then we leap to a conclusion, therefore, copper conducts electricity. It's when we're going from the particular to the general, from examples to a rule. Okay? Now, here's the thing. Seems like we use these a lot in science. There's actually some debate about how frequently we do this in science. And there's some debate about how induction relates to abduction. Some people think all induction's ultimately abduction, vice versa. Let's not concern ourselves with that. But arguably, here, let me just give you like one quick argument for thinking that we use this in science all the time. We have these laws of physics. Roughly, and there's a bit of a rub with this, but we don't have to worry about that either here. Roughly, a law is something that's supposed to hold at all places, all times in the universe, right? So if you take like a simple statement of a law from, let's say, classical physics, Newtonian physics, classical mechanics, Newtonian mechanics, these are all the same thing. We take a simple law like force equals mass times acceleration, F equals ma. The idea under Newton's physics was that that equation, F equals ma, is supposed to hold everywhere in the whole universe, not just on Earth, but on the moon, in between galaxies, you name it. Right? It's supposed to hold everywhere. And we're writing these things up with math, and the math always holds, right? Like, 2 always equals 2, right? 2 always equals 1 plus 1. Like, you got it. Okay. So here's and a lot of physicists will describe physics as the search for laws of nature. Well, here's a really good question. How do you know that that law really holds in all times, all places? Well, because it always has. Well, just because something has always happened doesn't mean it always will. And by the way, when you say it always has, you haven't actually seen, you didn't have your eyes on like every piece of space, space-time going back to the Big Bang. What you really mean is every time I saw the first thing, the second thing happened. Every time I saw F, I saw MA, equaling F, right? That's all you mean. You're basically saying, well, it happened 10,000 times and we never saw it not happen. Therefore, we're going to assume it always happens. That's invalid. That is invalid. We've had plenty of times where every time we saw A, we saw B until one day we didn't. Now, by the way, I could be wrong about this. I keep meaning to look it up. I keep forgetting. But I have a buddy who's a biology professor who told me we actually did finally find a non-carnivorous species of spider. He said that forever and a day, biologists, zoologists said all spiders are carnivorous. Well, actually, we found one that's not. Now, maybe I got that messed up or that person got that messed up. But this stuff happens in science. It happens in everyday life all the time. So these inductive arguments, they're not valid. You don't have a 100% guarantee that just because something always happened, it always will. Or just because you always saw it happen, it always will. Of course, it's not a 100% guarantee. But it seems like we use these arguments in science. We use them in everyday life. Some of these arguments that we think are really good one day turn out to be bad the next day. There's a really hard question here of like, how do you know which ones are good? And you don't have anything like 100% guarantee on that. But like, okay, what do you do with that? So a lot of interesting things to be said. Anyhow, this is induction. This is induction. Statistical generalization, or again, a more classic form is, the first F was G, the second F was G, the third F was G, ... the 10,000th F was G, therefore all Fs are G. And by the way, I'm not saying you got to always look at 10,000 and only 10,000. Sometimes we make these inductions off of like 4 examples, sometimes off of 1, which, maybe not great. A lot of times in science, we do have a lot more than that, but not necessarily 10,000. My guess is there's not 10, I don't know, are there 10,000 species of spiders? I have no idea. It could be a lot more, it could be a lot less. How do I know? I don't do that thing. That's out of my wheelhouse, but my guess is, I don't know. Did we have to look at 10,000 species of spider before we said that? I don't know. Okay. 6, based on the videos in the chapter, would you say that inductive arguments are deductive or amblative? They're amblative. I just went over that, not deductive. 7, are all deductive arguments good? If not, provide an example of a deductive argument that isn't good. Explain why it's not good. You can copy Pinners over here. So yeah, they're not all good, at least not all good. Pinn gives an example. Premise number 1, Beyonce was born in Paris. Premise number 2, everyone who is born in Paris loves cheese. Therefore, Beyonce loves cheese. That is valid. If the premises were true, the conclusion would have to be true, 100%. The premises are both false. Beyonce was not born in Paris. Pinn said she's born in Houston, around Houston. 2, probably not everybody who was born in Paris loves cheese. Both the premises are false. So the argument is bad, or at least partly bad. I mean, bad in a key way, if the whole point of an argument is to get us to truth. But the content's bad, premises are false, conclusions false. Actually, I don't know, maybe conclusion's true. Maybe Beyonce loves cheese. But if she does, that's an accident. But maybe we even imagine Beyonce hates cheese, right? Maybe, I don't know, she just totally abominates cheese, right? So it could be it's all false. Well, obviously, the argument's not good if what we want out of an argument is truth. And yet the argument can be good in a sense that it's got this wonderful structure. It's valid. If the premises are true, the conclusion would have to be true 100%. And then again, we can go on to ask, why are we so confident that if the premises are true, the conclusion's got to be true 100%? We talk about the form. Sorry, my phone's going on there, going off there, but yeah, okay. So, premise number 8, are all amblative arguments bad? If not, provide an example of an amblative argument that's good. Explain why it's good. They're not all bad. A lot of them are great. We use them in science all the time. Sober actually talked about Mendel's discovery of genes as being an example of an amblative argument and inference to the best explanation. That's great. One problem actually with Sober, his discussion of Mendel on genes, he describes genes as particles. I got to warn you, a lot of scientists now say that's wrong. We tended to, ancient people who believed in atoms, there were many. They often thought of as far as I know, they always thought of the atoms as solid. They didn't necessarily all think about them as balls. They thought they could have different shapes. They did have different shapes. Some of them also thought atoms could be really big. What made an atom wasn't its size. It wasn't that it was so tiny. It's that it was uncuttable, which is basically what the term literally means. Atom, incapable of being cut, right? They thought that atoms couldn't be broken apart into smaller bits. They weren't like made out of smaller parts that could be detached. They were solid in a completely unbreakable way, even if they could be big. Right, I think there were some ancient Greek atomists that said you could technically have an atom as big as a whole cosmos, but we know. I mean, that's not our picture of atoms today, right? You'll hear sometimes people say atoms are mostly empty space. Scientists actually say no, that's not. Don't say that either. That's not right. But the idea that they're perfectly solid is also not right. So sometimes it happens. We start believing in something, we have debates about whether it's really there, then we get kind of convinced it's there, then we kind of learn the way we thought about it originally isn't quite right. When we started talking about genes, when Mendel started all this, not that long ago, he thought about genes. Actually, I don't know. Did he himself really think about it this way? Did he describe it this way? Actually, I should be careful. I don't know exactly what Mendel himself said, but for a long time, scientists, they really thought of, and by a long time I mean a couple of decades, right? They thought about genes as kind of like particles, like atoms or something. A lot of scientists now are saying genes are actually way more complicated than that. You shouldn't think of them as particles. So, if you're out there, you make a ninth edition of the book, take that out, right? And if viewer, if you're curious about that, I can give you all kinds of sources on this by biologists. All right, so the Mendel example, Mendel's discovery of the genes was an example of an ambulative argument, inference is the best explanation. Pinn also gave one, which we'll turn to now, the discovery of Neptune. All right, so question number 9, Pinn mentions one example of an abductive argument. It was used in modern science. What is it? Do you think it's good? Why or why not? It was a discovery of Neptune, and here's how this went. We were using Newton's theory of physics at the time, which has been replaced by other theories, special relativity, general relativity, quantum mechanics, statistical mechanics, but back then we were operating with Newton's theory, which was pretty amazing, and you could still use it for all kinds of applications today. And people are looking up in space with telescopes, which I think only go back to the early 1600s, right? About thereabouts. And they're looking at Uranus, this planet up in space, Uranus, and they're seeing that its orbit is kind of funny, right? It's kind of funny, at least funny given Newton's theory. If you accept Newton's theory of, Newton's theory of gravity, which people did back then, and then you looked at Uranus, you would say, that looks kind of weird. It's not what we're supposed to see. And there are a couple main ways to explain that. One way to explain it was, well, Newton's theory is wrong, which actually we now know is the case, but they didn't really have, good evidence for that back then. At least not that they were able to put together at that time, like Einstein and others later would. But what happened was they realized that if Newton's theory is right, and again, it does actually work for a lot of applications, right? So I think this whole argument would carry over actually on, the theories of physics that supplanted Newton. If the theory's right, and Uranus is really doing what it looks like it's doing, there's got to be another massive object out there. There's got to be like another planet out there that's causing Uranus to behave this way. And it turned out they were right. It was Neptune. That's kind of how we discovered Neptune. And you start looking around for that thing more and you find Neptune out there. I don't know. Do you think it's a good argument? I say it looks pretty good to me. I'd say it's like one of the masterpieces of science, right? It's not deductive. It's not. It's technically not, right? But it's still really great. Again, we often don't get 100% in life, but sometimes even without 100%, you're pretty great. Michael Jordan wasn't 100%. It's pretty great. Ambulative can be pretty great. 10, Pinn mentions 2 factors that might make an abductive argument good. What are they? Do you agree? Why or why not? So the first one was fit with what we already know. So again, he goes back to this example, of the discovery of Neptune. So they were assuming that Newton's theory of gravity was actually right, or at least that it held, at least that it worked, right? By the way, some people say in science you shouldn't really say that the thing is true. You should just say it holds. You just say it works, whatever. So, again, it's not getting to the weeds on that. But that this postulation of another planet, this postulation of Neptune, that there's this other planet out there, presuppose Newton's theory is true or just that it works. Well, that did fit what they knew, right? With their evidence, at least, they thought they knew. So that seems to be good, if it fits with what we already know. You know what I'm saying? One way to think about this is that if I see something kind of weird in the sky that doesn't seem to fit any known scientific theory at all, and I just immediately say, all science is wrong, I mean, that's kind of ridiculous. You know what I mean? Like, we got a lot of good evidence for that stuff, and that we haven't even really started to investigate the thing I saw. I mean, plenty of these alleged UFOs. First of all, we're not assuming that they're refuting our theories of physics. They're supposed to operate on physics basically as we understand it, even if we think, oh, if it's a real UFO, there's a lot we don't understand. But we've never really we've never seen a real like flying saucer. I mean, and we never, I mean, like you got to investigate before you could say that UFO is a real flying saucer. The thing you don't know what it is, it's a real flying saucer, right? Like you can't just, okay. So if I see this thing in the sky casually and I don't know what it is, for me to say, oh, all the laws of physics are false before I do any investigating, that's crazy. For me to say it's an actual flying saucer without doing any investigating, that's crazy. These things are not fitting with what we already know. So a factor that makes an explanation good, an abductive argument good, it fits with what we already know, though sometimes that stuff turns out to be wrong, okay? And two, simplicity. Occam's razor. Occam's razor is actually really complicated. The role it actually plays in science is a lot more complicated than we're often led to believe. But if I see something kind of funny up in the sky and I say, oh, it's Darth Vader. Oh, I mean, that's ridiculous. You know what I'm saying? Pinn says what makes abductive arguments good fits with what we already know. Simplicity. This stuff isn't perfect. It's not 100%, but you can make some arguments. They're pretty good guides, at least in a lot of contexts. Okay, but do you agree? Where, why not? I'm leading you a little bit here. 11. Pinn mentions two ways one might challenge an abductive argument. What are they? Do you agree? Where, why not? So one is come up with a better explanation. So this could be better fit with what we know, simpler, etc. Right? So if somebody, like I'm out with a buddy in the street and we look up at the sky, we see something funny, and he says, it's Darth Vader's ship, or it's Han Solo on the Millennium Falcon. I assume you all have some basic knowledge of Star Wars. I think I can come up with a better explanation by just coming up with anything simple. How about it's just an airplane? Maybe not the Millennium Falcon, maybe not the Death Star, right? Or again, if they come up with an explanation that explodes all science, maybe I come up with something that fits science, right? I should come up with a better explanation, right? And that's how you could refute somebody's, and look for more evidence, is looking for more evidence. So the example that Pinn gives here, I think is really good. It's really interesting. So go back to one. Come up with a better explanation. So maybe we learn about a murder. We learn about a murder, and someone comes up with this really unbelievably elaborate explanation for it, right? Well, we're probably going to discount that, on grounds of simplicity. But sometimes it really could be elaborate. Sometimes it really could be. And so sometimes you can actually refute, for example, a simpler explanation with a more complex one if you have some real evidence of complexity. So the example that Pinn uses is that, so there's a murder takes place. The detectives, they have a suspect, right? And the suspect says, I'm being framed. The DNA and everything's a frame. I have this very powerful enemy who's been trying to undermine me for years. And finally, they're getting their way, and you're helping them. You're tools of I don't know, Lex Luthor, whatever. And the detective's going to laugh at this. Crazy. We've got all this really good evidence. We've got, got you the videotape, DNA, da-da-da-da-da, all kinds of eyewitnesses, da-da-da-da-da. And then suppose the detective actually does stumble on some really, really, really good evidence that this person really does have this very powerful, very rich enemy, this nemesis, who has been plotting for years to try to frame them for murder in this kind of way. Well, I mean, that if he actually had really good evidence for that, yeah. I mean, you know what I mean? That's you want to take that into consideration. I mean, obviously, these kind of things are extremely rare, but there it would go. So yeah, 11, coming up with a better explanation and looking for more evidence. All right, let's wrap this up pretty quickly. So I gave you a number of arguments here and then asked for you to classify them yourself as deductive, inductive, or abductive. So 12. Sully is a Mets fan, and he's a good person. Wolfie is a Mets fan, and he's a good person. Alice is a Mets fan, and she's a good person. Conclusion, every Mets fan is a good person. This is inductive. It's statistical generalization. It's moving from the particular to the universal. The first F is G, the second F is G, the third F is G, therefore all F's are G. It's inductive. Okay. It's not deductive. The premises definitely don't guarantee the truth of the conclusion. And it's not abductive. There's no explanation here. It's just generalizing a pattern. That's it. 13. I mean, you might think there's a reason why that pattern would hold, but that's not what this argument's giving you. 13. Two premises. 1, every Mets fan is a good person. 2, Sully is a Mets fan. Therefore, Sully is a good person. That's deductive. All F's are G, A is F, A is G. All humans are mortal. Socrates is a human. Socrates is mortal. It's deductive. Now you might say, but that's a ridiculous argument. Yeah. But again, whether it's, deductive has nothing to do with whether the premises are true. It's whether the conclusion would have to follow if the premises were true. And yeah, if all F's are G and A is an F, A is a G. End of story, right? 14. 3 premises. Pilar was in a really good mood this afternoon. The Mets won a big game this afternoon. Pilar is a huge Mets fan. Conclusion. Pilar was in a really good mood this afternoon because the Mets won. That's abductive. It's not deductive. It's not inductive. It's giving an explanation. It's an inference of the best explanation, right? 15. This one is really long. I'm just going to... There's 7 premises here. Let me just cut to the chase. This is abductive. Again, it's not deductive. The premises could be true. The conclusion could be false. We're not engaging in an induction. We're not trying to form some generalization about dogs and cheese, all dogs loving cheese, which actually I think that's a pretty darn good induction. This dog likes cheese, that dog likes cheese, the other dogs like cheese, 10,000 dogs like cheese, they all like cheese, or maybe a little more safely, almost all like cheese. That sounds pretty good to me. But this is an abduction. We're explaining what happened to the cheese. The dog ate it. All right, 16. 2 premises. 1, all vegetarians like broccoli. All vegans are vegetarians. Therefore, all vegans like broccoli. Yeah, that's deductive, right? Yeah. We're saying all vegetarians like broccoli. Again, whether it's deductive or not, has nothing to do with whether the premise is true. There could be a zillion vegetarians who despise broccoli. It's irrelevant to whether the argument is valid. It matters to whether it's sound. Sound is valid plus all the premises are true, but it's not relevant to whether it's valid, right? If we imagine a universe where every single vegetarian, however many, like broccoli, and we imagine that all vegans are vegetarian, that follows from the definitions of vegan and vegetarian, it would have to be in that universe that all vegans like broccoli. However many verses you've got where the premises hold, the conclusion's got to hold. Has to, right? If the premises are true, conclusion's got to be true. 17, 2 premises. When we went out for burgers last week at Five Guys, Pilar ordered a veggie burger. 2 Five Guy meat burgers are really good. Therefore, Pilar must be a vegetarian. Again, this is abduction, inference to the best explanation. It's definitely not deductive. It's really not inductive. It's an inference to the best explanation. Is it a good argument? I don't know that it is. To say must, we'd have to really ask ourselves, I don't know, does maybe Pilar is, maybe Pilar is not vegetarian, but maybe she just doesn't eat red meat. Maybe it's Friday and Lent and she's fasting. I mean, there's all kinds of reasons, there's all kinds of reasons why, it could be she didn't order a meat burger, that she ordered a veggie burger, even if she's not vegetarian, right? 18. 1 premise. Every student at COD that I have talked to plays Nintendo. Therefore, every student at COD plays Nintendo. That's inductive. It's a statistical generalization, right? That one's a little bit tricky because it's got the every. But yeah, it's statistical generalization. It's induction. I'm basically, all the ones I've met do, therefore they all do. It's not deductive. There's no explanation going on. It's statistical generalization. It's inductive. All right, y'all. Use these. Fix up the assignments. The assignment submissions. Resubmit. Hope you learned a lot from this. Peace.